to introduce our topic and speakers today, and then we will go ahead and get started.
Yeah, sounds good. Thanks, JT. Yeah, I'm Justin. I'm an ontologist and software engineer here at Semantic Arts. I'll do maybe just a few more than a couple words to give a little background. So a couple years ago, I was on a team doing knowledge graph construction. We had some ontologists, we had a data analyst, and we had some software engineers. And we were looking for a way to construct graphs, RDF graphs, in such a way where everybody could participate in the development and in the maintenance. And we didn't want there to be ripple effects. Like, you know, if something changed upstream in the design, we didn't want there to be kind of this long lag to get the changes into the actual graph. We tried a lot of approaches, in everything from annotating spreadsheets to just having the ontologist basically type out the triples that they saw for a given slice of the data. And eventually we came across the SPARQL Anything project, and it seemed like a fantastic a fit for our goals. And we started using it internally just to try it out. I added a couple features to the tool and met Enrico and Luigi. They're the primary developers on the project. And then it became our main production system. It was the core component in our triplification pipeline. We used it to produce billions of triples. Not all of those stayed resident in the graph. Some were transitory, but it definitely held up well to the task of enterprise knowledge graph construction. And I've even written an open source tool based around it that translates Git repositories into RDF graphs. So it's a fantastic tool, yeah, I think it was a great idea. I don't know much about whose idea it was, if it was Enrico's or Luigi's, but it's a fantastic thinking. So with that, I'll turn it over to Enrico.
Thank you, Justin. It was a joint effort. We started to work on this, as Justin said, a few years ago, and me and Luigi, work with knowledge graph since many years, about more than 10 years of experience. And we are both kind of researchers, but mainly we develop things, we build things in our research. We are in the team, we are always been the builders somehow. And so we always had kind of this, the knowledge graph construction problem as a kind of everyday problem for us. So we built knowledge graphs in many different projects and domains. So the way we wanted to do this, we talked a bit with Luigi. So I will give an overview of the overall idea and kind of what's behind in terms of methodology and concept, and illustrate a bit kind of the research that's behind the SPARQL Anything and the open source project, and why Luigi will give you a bit of details on how the tool can be actually used in practice. Okay, so if that's all right, maybe I can share my screen and we start. Cool.
Yep, very good. You should be able to share. I think I've got the permissions right.
I should be. Let me try and do that. So if I do this, and let me see if I can also present. Going to presentation mode. Can you still see my slide if I do that?
I think we're still seeing your presenter side.
Okay, then let me change that. Okay, so if I do this? Yeah, so it's not presentation mode, but it looks like. Okay.
That looks good. You probably won't be able to see hands that go up during the presentation. Do you want me to call those out or just kind of wait until you finished, or what do you prefer?
No, I don't mind. I think if you want to interrupt and make questions, that's absolutely fine. Otherwise, we can take 5 minutes between the two presentations and for questions.
Yep.
That's okay.
Very good.
Okay, so let's set the scene. So as I was saying, we deal with knowledge graphs, we build knowledge graphs and RDF databases for a while, and clearly this is the main problem is how do we transform the data, and there has been a lot of work on this, but our angle was mainly that in many cases this kind of the coming tool work with some common formats like JSON files, CSVs, databases, and we often found that sources can be actually really anything. It can be web pages, they can be BibTeX files, can be Markdown files, and in one of our recent projects, XMLs representing the music scores, for example. So really the question was how do we go beyond that? So if we look at the current kind of offer in terms of toolkit, the current the offer that we had before coming with our solution, either they were targeting specific formats and types, so you have to change tool depending on what is the source. Those tools lack generality, or there are specialized mapping languages which require some kind of high learning demands. You need to learn a new kind of model, new meta model, and try to study how it fits with the actual source type, and then design all the mappings. And also these tools are usually limited to few popular formats, and they are quite difficult to extend to new format. And actually, in the end, you want the knowledge graph. You don't want necessarily to expand and extend a tool to build knowledge graph. So you want to really something that can quickly give you a tool to do the work. Other approaches extend SPARQL, which is also our perspective, but they extend it in a way that goes far beyond the specification. This means essentially equates to generate to make a new tool. That's the case of SPARQL Generate. And in any case, these solutions have this kind of design issue from our perspective. They move the complexity of the source to the user. So if you want to extract data from a JSON file, you need to know JSON and JSON path. If you want to extract data from an XML, you need to know XPath, and so forth. So really the question for us is first of all, how do we find a solution that is potentially applicable to any structured data source, any format, and is extensible so that users don't have to learn new features of the tool for each one of the data formats, and also considering something that can be ready usable by knowledge graph practitioners. And many SPARQL users are not software engineers. Okay, so many knowledge graph practitioners are not software engineers. So what we really want to address is build something that is readily usable for them. So then what is the principle behind? So then what we did is we looked at the process of knowledge graph construction. So usually when we build knowledge graphs, we observe the source and we design some sort of mappings with some tool. We may write our own code, or we may use an existing tool. Then we look at the outputs, and then we kind of compare with what we want to achieve, and we go in iteration in a trial and error way. Okay. So, but actually, when you look at this process, you look at the cognitive process of the developer or the knowledge graph practitioner, building this pipeline. Actually, the kind of the work is targeted to two distinct operations. One is what we call reengineering. So you take a meta model, which may be the JSON meta model, the relational data model, and a target meta model, which is RDF in this case. And then you have a modeling work. Now you take a schema, a representation of a source representation, and you want to target representation, which usually is your own ontology. So essentially, our revised knowledge graph construction approach has this kind of distinction between reengineering and remodeling. So you observe the data source, we reflect on what kind of meta model we want, we reflect on the semantics of it, so which properties and types, and then we again execute the mappings, and we go can go in iterations. So looking into that, then we really thought that we could do all of it in SPARQL if we find a way to consider any data source as RDF. Okay, so the question is for us then became how to develop a unified approach to re-engineer an open-ended set of formats into RDF. If we get this RDF way for any data format, then the knowledge graph construction work will become essentially querying knowledge graphs to obtain new knowledge graphs. The concept is not new in terms of kind of design solutions. It comes from software engineering, object-oriented programming specifically, and it is the idea of the facade. So you essentially design an intermediate model that is a simplification of the underlying objects, and so that it essentially you have an abstraction that shows common features of different models. So in our way, then the question was, okay, let's do a facade, but then the question was, what components of RDF we want to consider, we want to use for this facade. So we have a problem space, which is CSV, JSON, HTML, XML, and so forth, and a solution space, which for us was RDF schema, so the simplest possible way. So the intuition is everything can be abstracted in RDF. And then, in fact, if we look at the very different formats, we see that there are some minimal set of primitives. We have typing, that here is in these examples are in orange. That's an article, that's a markdown header, and that's an element type for XML and HTML. There are keys like the journal for BibTeX and so forth, and there are positions in sequences, right? The first child, second child in these kind of nodes. Okay. So with these tools, the idea is that we can design a kind of RDF metamodel, a simplified RDF metamodel, to potentially map any other format. And this is what we called FacadeX. That is basically a restriction on RDF. So FacadeX allows typing. It imposes one root, which is the root of the document. And that's the only term that we actually declare. But all the others are derived from the source, all the keys. And then we use container membership properties for sequences, and literals and types and so forth. Okay. So these are a few examples. So that's how a piece of JSON may look like. As you can see, there is a kind of mimicking the source. On the left, you can see the JSON snippet. On the right, the respective FacadeX RDF snippet. HTML, you can use elements as types, and then attributes as key and values, and containment is expressed as sequences. So you get the DOM tree, a nice DOM tree, only using these components. CSV, very intuitive as well. You have a list of lists essentially. And if you know that the CSV has headers, you can even use them for expressing keys and so forth. This is an example for bibliography. So essentially, if this is possible, then this means that we can express mappings in plain SPARQL. Okay, so we get the source data. We can query this source data with in SPARQL. We can transform the data and project the results into a construct. So we can do everything in plain SPARQL. So the idea, the user doesn't need to know anything else than the basic RDF, the basic toolkit for knowledge graphs, which is essentially RDF and SPARQL. Okay. So this is the idea behind this project. It's called SPARQL Anything, and development started a couple of years ago, and it includes quite a wide range of features. There are many supported formats, and also some of them are not supported by other tools. You can query the file system, you can query archives, you can query a markdown file, YAML files, BibTeX, you can even query a Word document. And you can work with files, inline content, you can chain external commands. There's a full-fledged HTTP client, so you can reason on the HTTP response headers, for example. And we extended the functions of SPARQL. There's a library of extended functions and magic properties. Luigi will tell a bit more about this. We can use parameterized queries, and there is a quite flexible command line interface. There is we can triplify in memory or use an on-disk option as well. And I can show you a few examples from our work. In this one, we are essentially browsing a file system of files. We have a CSV, which lists all the JSON files. So we go through the CSV first in one service clause, and then we query each one of the JSON files and get the details about the artworks. So you can nice thing you can change when you have this approach of using service clauses to connect to non-RDF sources. You can combine things. You can chain operations and write quite complex pipelines if you want. The command line interface has a number of features, and here in this short tutorial, we show how we can scrape a website, and we extract data from HTML in a number of steps. So we get all the list of the artists, we get to the artist page, we extract bits and pieces with few SPARQL queries, and we build a knowledge graph from the museum catalog. We also worked on querying music scores. I collected a few really extreme examples just to give you the idea of how flexible this system is. And we extracted like bits and pieces from in relation of music scores. So like pieces of melodies, n-grams, and things that are useful for music information retrieval, music analysis. So this is a brief overview of the system. Essentially, this is developed on top of Apache Gina, the open source SPARQL Arc engine, and essentially it behaves as a standard SPARQL 1.1 query engine. Okay, internally, the sources are materialized in memory, and the SPARQL query is executed in memory. We implemented a few. One optimization mainly. This is the one of only triplifying, only loading in memory the parts of the source that is expressed in the query, using some kind of what we call triple filtering. And also there are other approaches to, for example, segment the source and only run the query on each specific slice, which is a bit more sophisticated, but essentially at the moment, what we do is we take the source, we build a knowledge graph, and we query it through the SPARQL service clause. So we ran a few rounds of evaluation from different perspectives, some empirical evaluations. We scrutinize the number of formats, and we keep seeing that new formats come, and we still can use the same facade. So essentially, the FacadeX meta model is robust enough. And also, we have compared kind of the cognitive complexity of mappings developed with SPARQL Anything with mappings developed with SPARQL Generate and RML or ShexML. And we have seen that SPARQL Anything queries are far more compact. So they use less tokens somehow. So they have a smaller number of tokens. And then we reflected on a kind of theoretical evaluations. So and this is something we published a paper, and there is a proof that any format expressible with a BNF grammar can be also represented as FacadeX, and this is the same potentially for the entity relation model, even if we haven't yet developed the functionality that allows to query relational databases. This is something we are working on. This is not yet part of the open source tool. So these are a couple of publications that came out in the last couple of years. And now we are under review. There is some work on these materialization approaches for querying FacadeX in SPARQL. And we're also studying kind of usability issues to kind of understand how to improve the generation of mappings for knowledge graph construction. So essentially, this is a summary of what we have. So SPARQL Anything allows transform and query resources from many formats. It has low learning demands for knowledge graph practitioners. They only need to know SPARQL 1.1. It is a single consistent abstraction, potentially for any data format. So we are very open to get requests and also help in building new connectors to any formats. And I think this is one of the few tools that allow to explore the data before knowing it. So you can really connect to the data source directly in SPARQL and just do general queries for exploring the data. And this is really not common for most of the other tools. Usually you need to open the original format and kind of try to translate in your mind the original source into the knowledge graph. There is an open-ended extendability. As I said, FacadeX can express any format. So we add the supported format, the tool doesn't change, and we can generate RDF star, thanks to Apache Gina and the standard SPARQL 1.1 query engine, but also tabular data, which is very useful. Sometimes I find myself using this tool just for querying stuff. If I want to query a CSV file, I use SPARQL Anything. I don't need to build a knowledge graph, but it just comes in hand. A few people that collaborated so far, and we are very open to new collaborations. So thank you. If there is any question, just either I or Luigi can happy to answer them.
There was one question in the chat. Have you compared with TARQL for CSV processing?
We haven't done kind of, you mean compared in terms of performance evaluation or in terms of, in what terms?
Sorry, Pete, I don't know if you want to turn your mic on and.
Yeah, I mean both, mainly in terms of scalability and performance.
No, we haven't. No, we haven't.
Okay.
We have done some scalability performance tests in comparison to RML Mapper, SPARQL Generate, and ShexML. And but no, not TARQL. Maybe mainly because TARQL is targeted to one format only.
Yeah.
But actually, that may be something we should probably do. So no, I don't know if Justin, maybe you have some experience with TARQL. I heard in a few discussions we had before. Maybe you have some insight on how.
Well, I mean,
Sorry for calling you in.
Oh, that's okay. Yeah. Oh, well, given that SPARQL Anything supports CSV like TARQL and so many other formats, I basically consider SPARQL Anything the successor to TARQL. So I think TARQL is a great tool, and I think SPARQL Anything just continues in that sort of the thinking that SPARQL construct queries are quite powerful transformation. It's a powerful transformation language.
Yeah, Rebecca's got her hand up.
Yeah, one of the things we found useful about SPARQL Anything that TARQL can do is to process more than one file at a time. So if you have to cross-reference between CSVs, in TARQL you have to load one into a triple store and then do a federated query to the triple store rather than being able to process the two files at once in a single script.
Cool.
Over.
Yeah, I think one of the kind of the things that we like most is this ability of chaining chaining different operations. Yeah. That comes very useful. That's very useful.
Peter Huxley.
Sure. I must say I've learned about the tool last week, and I think on Friday I worked on it, and Monday I worked on it, and it's already up and running, and I've been able to convert a, I don't know, 11 tab Excel file into triples. So I think it's really fantastic in terms of the time saving that it provides, and just the prospect of having different formats, and that anybody can dump any type of, I mean, any type of data on any kind of form, and you can convert it. I think it's really fantastic. As a question that I have, is there any way to kind of do a full pipeline run? Let's say if I have the SPARQL file, meaning the query file, and I have an input, or I have a what's it called, a directory with files in it. Is there a way to just schedule the tool and then have the tool also inject the generated triples into a triple store, you know, to have kind of the full flow of the generation?
Yes, to a certain extent. So this is something we are really discovering while we do it. So usually what we do so far, we decompose the process in a number of steps. Like we have parameterized queries, for example. So if we look at the case of the web scraping here, so what we find useful if we decompose the process here, for example, in the first call, we query the web page with the list of artists. There is an A to Z list of artists with links, no? And I generate essentially an XML SPARQL result set with all the name of the artist and the links, no? And then in the other one, in the second call, we essentially use the result set as query parameters. So we run one query on each one of the artist page, and we generate a collection of JSON LD files, no? And that's how we do that. So that, for example, here as output in the artists folder, there will be one JSON LD file for each one of the artist nicknames that are from the SPARQL result set in my artists. And then what we do next in this tutorial, we query the folder in the sense that with the -L option, the command line loads all the JSON LD files in memory, and you query it as if it was already a knowledge graph. Because from the artist's web page, we get information about the artworks link. No? So, but here I do it for the intermediate kind of knowledge graphs, and I get a result set of artworks link, and then in the last call, I do the same trick, and I use the result set as a collection of parameters to run the query multiple times and generate one JSON LD file for each artwork. So there is some level of automation that you can implement by chaining the various functionalities of the command line. So that's one way. The other way that you can kind of automate things is by chaining different service clauses altogether. For example, in this example, I use the artwork data CSV as a catalog, and then I query the single files on the file system, because I can, with a kind of a bit cumbersome process, you can see this, I can build the path to the JSON file, you know? And this is just really what we did with this data source. This is not a made example, so it's not. It's really how the actual data source was, which is this one is the Tate Gallery open data. It was released on GitHub like 2014, something like that.
Nice, yeah. And the actual injection of the triples into the triple store?
Well, that's something that's not supported yet. We only support, we only support select, asks only the querying part, not the SPARQL update.
Yeah, okay. That answers my question.
But I think this is mainly for software thing, in the sense that I think that the same approach could apply also, so I think that software can be easily extended to support insert and other SPARQL contexts. It's just we haven't done it because we didn't need it so far.
Yeah.
But
Well,
yeah,
you can do an insert. So if you write, say you have a triple store and you write an update query, if in your service clause you reference SPARQL anything, you can insert directly into a triple store by having a service clause to SPARQL anything. So that's how we typically do it.
but you do it, but you don't do it through the command line, Justin, right? You do it through the server eventually.
Well, I mean, it's command line in that it's a curl call, but yeah, I mean, yeah.
Yeah, no, maybe so. So I think that because now maybe I should pass the word to Luigi, because Luigi will tell you that there are a few ways you can use SPARQL anything, and so far I mainly talked about the command line interface, and I think the command line interface only accepts select and construct queries and ask queries, but there are other ways you can use SPARQL anything, and yes, I will not be surprised to see this working normally while using, for example, the Fuseki server. Yeah, just I haven't done it.
Yeah. That's also from my side the same, because I think that it works, but we never use it in this way. But something that we should we should try
Explore
at least.
that,
Yeah.
we should explore that a bit, so that also that we can provide a bit of documentation and corner cases and examples.
Yeah.
So
But
I pass the stage to you, Luigi.
thank
What
you very
about
much. I don't know if there are any other questions.
I don't see any other hands, so I think you're good to keep going.
Okay. I share my screen. Can you see the slides?
Yes, that looks good.
Yeah. Okay. I'm Luigi Esprino. I'm an assistant professor from the University of Bologna, and this part of the presentation, in this part of the presentation, we will give you a brief overview of the main feature of the SPARQL Anything tool. Let's go back for a second to the general approach. So suppose that we have a JSON file here, a JSON file containing names and addresses of movie characters in this case, and we want to extract the address of one of them, for example, Gordon Gekko. So, and after the Enrico's presentation, you know that this is something you can do with SPARQL Anything. And let's see how the actual query looks like. So one would expect to write something like this query. You have to select the address of someone whose name is the string Gordon Gekko. And actually the SPARQL Anything query is really close to this one. You just need to add a service clause in which you basically specify here the location, the URL of the input file, and you also have to add the namespace prefixes for the properties as the FacadeX meta model defines. And once you have this query, you can submit it to the SPARQL Anything engine, and the engine does this default simplification according to the facade meta model, and then evaluates the query over this RDF graph and returns the result. So this is the main, the general approach. And here is an example with select queries, but of course you can write construct queries, ask queries as well. And the outline of this presentation is supposed to be very practical and give you an overview of the main features. So let's first, we'll see how to use SPARQL Anything, some details, basically pointers to the supported formats, and we'll see how to configure SPARQL Anything and how to use SPARQL Anything custom operators. So how to use SPARQL Anything? SPARQL Anything is released as executable JARS files. So you need Java runtime environment to be installed on your laptop. Each release comprises basically two executable files. One is for running the command line interface, and the other is for the web-based graphical user interface. So the command line interface is basically an executable file which allows you to fire queries from your terminal. You have a list of a set of features, provides a set of features for controlling input, output of the process. But also one of my favorite feature is that allows you to write query templates. So what is a query template? Is basically a query in which you have placeholders. This placeholder will be filled by the command line interface before executing the query with values provided in the command line. Like in this example, we provide the URL of the input file from the command line, and before executing the query, the engine does this substitution. And you can also use SPARQL Anything via a web-based graphical user interface, which is basically a Fuseki server in which we integrated the SPARQL engine. And this Fuseki servers has also been embedded into a Docker container, so you can deploy this Fuseki server very easily. And this Fuseki server comes with a really nice SPARQL editor provided by YasGUI, which provides syntax checking, syntax highlighting, code completion that are useful when you write query. The other way of using SPARQL Anything, if you are a Python developer, is to use the PySparkle Anything library, which is a library basically that allows you to run SPARQL Anything commands within your Python scripts and process the result of the commands as a Python data structure. For example, ask returns Boolean values, construct returns RDF-lib graphs, and so you can more easily process the result of the SPARQL Anything command. Details on supported format. Well, Enrico already gave us an overview of the FacadeX meta model, and if you are curious about how this meta model is instantiated for each supported format, in the GitHub repository you'll find one dedicated page for each supported format. We don't have, of course, the time to go into the details of each format. How to configure SPARQL Anything? Well, the default replication performed by the tool can be controlled by options that are passed within the query. In SPARQL Anything, we have two types of options: general purpose options, which apply for every data format, and format specific options, which applies for, of course, specific formats. Options can be passed in the service IRI, and here is the schema of this IRI. We have defined a URI scheme, which is X -SPARQL anything, and you can have a really simple the simplest service IRI, in which you just specify the input file to be processed by the tool, or you can specify in the service IRI a command separated list of option value pairs, which will be passed to the SPARQL Anything engine. Here is an example in which we pass just two options. One is for telling the engine what file what is the input file, and the other namespace is for controlling the namespace used by the engine for minting the properties of the properties generated in the default multiplication. You can also pass options in the basic graph pattern. Here, actually, we force the SPARQL language, but this is very useful when you have multiple options. And in this, you can pass options as triples of the basic graph patterns of the basic graph pattern of the service clause, and each one triple for each option, in which the subject of the triple is fx properties. The predicate is the prefix fx concatenated with the name of the properties, like fx location, and the object of the triples is the value of the option. And of course, these triples won't be considered by the engine during the processing, are just ignored. Here is a list of general purpose options, location for telling if we want to, for example, simplify a file, or if we want to simplify a string that we pass within the query as a literal, we can use the content option. Or if you want to simplify the output of another process, we can use the command option to tell the engine to run a specific command, take the output of this command, and process this output like as an input of SPARQL anything. And also you have other options that you can use for manipulating the default simplification. And as I was saying, you also have format-specific options. One, for example, in JSON, we have the JSON dot path option that allows you to select a specific portion of the JSON file to be considered as an input of the process. In this, you can specify, for example, a JSON path to tell the engine just consider this part of the JSON file. And similarly, you have other options for other supported formats, CSV, HTML, and so on. We have defined specific SPARQL operators for SPARQL anything. Operators in SPARQL are magic properties and functions. These are in addition to the to the common SPARQL operators, and also to the those provided by Apache Gina. For example, we defined the fx, the magic property fx any slot, which matches any container membership property like rdf_1, _2, etc. Or the function ifx cardinal, which takes a container membership property like rdf_1 and returns an integer of the cardinal integer of the property like 1. In this example, we use another quite useful property, which is fx entity, which takes a list of SPARQL nodes and does the concatenation of this list and create an IRI. And this is useful, of course, for minting new resources. So that's basically it. I just want to stress that SPARQL Anything is an open source project. We have a GitHub repository in which we collect the code, of course, the code of behind the tool, but we also the documentation, and also we collect issues, we discuss ideas, features. So I invite you to take a look to the repository and also to participate to the discussion if you use it in your projects. So thank you very much for your attention, and that's it.
Excellent. Any questions? We'll do hands raised for questions or thoughts. Guys just presented so well. Everybody's quiet. Oh, there we go. Peter first.
So I wondered if you'd explored linking it up with some of the new technology that's out there, like ChatGPT or some of the other NLP approaches. And a separate question is whether you'd considered using SPARQL shackle shapes as applying shackle shapes, which again exist out there as a sort of pseudo ontology or set of shapes for filtering content and verifying content.
Well, we considered to define. We haven't done yet, but there is the idea of defining a shackle shape to verify the content, to verify if the RDF graph generated complies with the FacadeX specification. And yeah, that's something that we want to do in the future.
And you could potentially also use the shapes as like a view mechanism to filter and select information. Sorry? You could also use shackle shapes as more of a view mechanism, like a relational view, to filter and select properties from the RDF representing the input graph.
Yeah, we haven't. I mean, I don't know if Enrico wants to add. I'm not familiar actually with the shackle. I just know the language, but I never use it in the actually. So maybe Enrico wants to raise some ideas on that.
Yeah, I mean, no, that's actually a good point. We haven't explored a lot. We haven't explored how to use shackle with FacadeX data sources. We are building on the amazing Apache Gina, which includes also a shackle engine. So maybe one thing we could do is to start to explore how we can use the Gina implementation of shackle with the data sets generated by our FacadeX, and see how we can maybe extend the toolkit to also use shackle expressions as ways to query or to verify data that is non-RDF sources. That's actually an interesting use case. I haven't thought about it before. Thanks.
And my other question was whether you've done anything with linking up to ChatGPT or any of these NLP engines to take unstructured text as an input.
Not yet, but I remember some time ago, Luigi, you came out with the idea of AMR to RDFs, kind of.
Yeah.
So there is this abstract meaning representation that is one way in which natural language processing research kind of abstracts from texts, and builds these knowledge graphs. And Luigi had the idea, why don't we build a connector for an AMR data model to RDF, which is something doable, but just we haven't done it. But that's actually a very good point. And I know also about there is some graph GPT as well going, but I haven't tried it yet. So that's exciting times.
Michael Lashold.
Yeah, can you hear me?
Yep.
Barely.
Yes.
Might have to speak up a little bit.
Okay. So could you look at that example again a few slides ago on FX entity? I wasn't sure exactly what that was doing. Is that creating a new IRI by concatenating a bunch of things together?
Yeah. In this example, we concatenate the X prefix with the result of another function which encode, which basically takes a string and encoding and gives you here a safe ID to use to concatenate with the prefix. And the result of entity is an IRI, is which will be used to bind to the person variable, which will be used in the constructor to create an IRI for a person here.
Okay, so basically it just makes in this case, it just converted the space to a plus and it'll do anything else required. Okay, thanks.
No, yeah.
Yeah, I think entity is one of those. So there are a few extensions that we developed just for convenience. So essentially, since we do a lot of string typecasting and string concatenation for building URIs from data, then the entity operator does it automatically. So if it accepts integers or other data formats and casts to string internally. So this is why it's just, but it doesn't do anything different from what normally can be actually done in plain SPARQL. It just becomes less verbose, so it's just a convenience.
Thank you.
This is equivalent to the function FX entity is equivalent to the function IRI concat, which is are already provided in SPARQL. Here, FX entity is just a convenient shortcut.
Peter, hand up.
Yes, I was just curious. Should we still invest in R2RML, or is the relational database support coming soon?
We are working on it, but it's not coming soon.
Not coming soon. Okay.
We started working on it. Yeah, there is because in the case of, I mean, it could come like immediately, but in the sense that if we just assume that database is as if we had a collection of CSV files, then we could apply the same approach, load everything in memory, and query the various the resulting knowledge graph. It's just we are quite sure that in case of relational databases, we want to target large objects. So we are directly investing into looking into query rewriting approaches, which is much more difficult to do. This is why we will take some time. We are studying the theory now, and I mean, no, I hope in 1 year I hope to to have that published. But it's
Okay.
really something we're starting now, so it'll take a while.
Yeah. Cool. Thanks.
And we are open to collaborations. If anybody wants to invest in this, we are really, our doors are open.
I figured.
Because it is a paradigm shift. Because at the moment we take the input, generate the RDF graph, and then we query the result graph. But for this doesn't work for relational database or large or other large sources. So we are investing time to think about how to rewrite the SPARQL query so that we can write a SPARQL query in a SQL query, or to in a way that allows us to process more easily the source. This is why we are taking so many time.
Excellent. Well, very good. Well, thank you for presenting and sharing a little bit. I did post the link to the GitHub repository in the chat for anybody that wants to follow up that way. And again, we appreciate you taking some time to come share, and we'll go ahead and wrap it there and see everybody the first Thursday in June.
Thank you very much for inviting us. It's been a pleasure being here today. And thanks for the nice feedback from everyone. If please come and join the GitHub issues. So if you try it out, if you have bugs or questions or feature requests, please join the community and discuss. we're very happy to get ideas, feedback, and help. Thank you very much.
Yep. Thank you. All right.